Could you describe to us in detail how MQTT Sparkplug functions within an industrial IoT network?
Of course. So we say MQTT Sparkplug because essentially Sparkplug uses MQTT as the transport protocol. So you need an MQTT broker somewhere at a minimum, and maybe several depending, of course, of the kind of architecture that you have, or maybe a cluster aware or highly available broker depending on the functional and non-functional needs that you have. Okay, so you've got your broker. What Sparkplug adds on the top of plain MQTT, so to speak, is essentially three things. One, a standard payload format. Two, a topic namespace, in other words, a structure for your MQTT topics, which is predictable and customizable up to a point. But we have pretty strong opinions about the structure. And third is what we call stateful session management. In other words, we use some of the features available in MQTT, like the last will and testament, to make sure that we know at any given time if a device is online or not. And the same for the SCADA system. So if the SCADA system goes down, then we use the last will message on a specific topic that is defined just for that purpose that will be sent to every node. So maybe you buffer data locally while the SCADA system reboots and comes back or something like that. So that's at a high level how it works. Now, if we dig a bit on each of those dimensions, so focusing on the payload format, the way Sparkplug payloads are structured is not the same, let's say, as OPC UA information models. In OPC UA, they try to invent the perfect model for water pump or something like that, and then, okay, maybe you can add your own attributes, but yeah. So we don't care about that in Sparkplug. The payload is generic in the sense that it can represent any metric which is relevant to you, okay? So what we provide is a way to express those metrics, but it's up to you to define, okay, I want water pressure in PSI, or I want, the number of liters in a specific reservoir or something like that, okay? And that's really where Sparkplug shines, in the sense that because the payload format is standard, then any Sparkplug-enabled device or software component will be able to parse it and understand it. But at the same time, whatever data you put in there is up to you, and you get flexibility because of that. So in order to simplify things, we provide developers a schema for the payloads, and this schema is expressed in Google protocol buffers or protobufs, okay? So there are many language implementations for that, so whatever type of environment you have, you can use protobufs, and essentially when you have this schema which ships with the spec, you can generate skeletons for your code, and it simplifies development. So that's how it works for the payload. The topic namespace then, okay, is structured in a specific way. We start with the version of the protocol and the payload encoding. Okay, so currently for Sparkplug version 3, okay, this is /SPB, so that's payload format B, V10. And so this can get confusing because it's version 3 of the protocol, but it's version 1 of that particular payload encoding, and that's what we care about. So the next version of Sparkplug version 4, will likely introduce payload format C. So you can run both Sparkplug 3 and Sparkplug 4 on the same broker, because at the root, you have SPB or SPC eventually, for version 4. So you won't mix up, messages from a different version. So that's the first step. After that, you add the notion of a group ID. Okay, and the group ID is something arbitrary that you decide. So if you want to segregate things by country or by locations for your various factories, whatever you want, you put it there. Then you have the ID of the edge node. Okay, and the edge node in Sparkplug is really a node that speaks Sparkplug natively. So in some cases, you will stop there. Okay, it's really up to you. And in some other cases, you have non-Sparkplug devices connected to that edge node. Okay, maybe over Modbus or BACnet or whatever. And then what happens is that those devices can still be part of the namespace. So you will have a device ID after the node ID for those cases. Okay, and the device ID matches whatever is connected to the node. So a Sparkplug native device will maybe not have, those devices attached. It will be considered an edge node, but whatever, whatever floats your boat. So that's how things are structured. And then there is somewhere in the namespace, and memory escapes me, I don't remember at what location it is, but you have the message type.
Oh, yes.
Okay, so I think the message type comes before after the group ID, but before the edge node ID. And the message type, there are various message types in Sparkplug. So the first one is the birth or death certificate. So you send that when you have a new device joining, and you send the birth certificate saying, I'm device XYZ, I will report about those metrics. So every other node which is interested knows what this device will report about. And the death certificate, of course, is much simpler to say, I'm going out, so don't expect anything from me. Okay. Then there are data messages for both edge nodes and devices. So those are the regular metric updates that you send when there's a change. Don't forget that Sparkplug is report by exception. So if a message, a value is not changing, then you use retained messages, on a specific topic according to whatever makes sense for your use case. And you don't send other messages until the value changes, or maybe you want to refresh it for some reason, that's fine too. But ultimately, it's up to you to decide. And so those data messages are much simpler than the birth certificate because you don't repeat some of the information about the metric, of course. You don't have to repeat the unit of measurement because, you declare it once and then normally it shouldn't change in the middle of an industrial process. Anyway, then we have command messages as well that can be sent to edge nodes or devices. And commands will be interpreted by the device. So this is about opening a door, or activating a pump or something like that. So it is, of course, use case specific, but those messages are provided so that you can, actually do industrial automation in Sparkplug. And finally, there's a last message type, which is reserved for the SCADA system. So the specific topic where the SCADA system will tell nodes, hey, I'm online, or hey, I'm going out. And once again, typically those messages will be sent as last will and testaments in the case of disconnections, so that if there's a technical issue with the infrastructure, then at least the other nodes know that something is happening in the environment. So that's how the topic structure or the topic namespace is built in Sparkplug. And then the stateful session management, we talked already about it. So this is the notion that essentially I send my birth certificate, and then I set my last will and testament as Sparkplug edge node so that relevant information is sent when there's an accidental disconnect. And that's how it works. And between the two, you don't need to poll the device. You know, because of the properties of MQTT, that the device is actually online. So you save on bandwidth because of that.